Here we are in mid-chapter 7, exercises 28 through 33. It says rationalize the denominators. We remember that to rationalize means to make rational. In this case, these are irrational numbers, so we have fractions, so we get to times anything on the top and bottom that we want to turn these guys back into rational numbers on the denominators, even if the numerators aren't rational. So we think square root of 17, what can we times it by to make it a rational number? Well, its partner is itself, square root of 17 times square root of 17, and we get 5 square roots of 17 over square root of 17 times square root of 17 is 17. And look, this is now a rational number. Its partner with itself, you square something, and the square root and the square cancel out, and you're now left with a rational number. Great. Right here, yeah, square root of 6. Square root of 6, square root of 6. And that's 8 square roots of 6 over 6, because square root of 6 times square root of 6 is indeed 6. 8 over 6 can reduce down to 4 square root of 6 over 3. So there it is simplified. All right, so number 30. We only need to get rid of the square root of 6. So let's times by square root of 6, square root of 6, and we get 6 square roots of 6 over 4 times square root of 6 times square root of 6 is the number 6. Now notice we could write 24, but it's going to simplify like this, and we get square root of 6 over 4. Yeah, good. And we have a denominator that is now rational. All right, number 31. How do we rationalize this one? If we times by the 4th root of x, well, then we get the 4th root of x squared. It doesn't undo each other. So we've got to times by the 4th root of something that will make this a 4th power. So we've got to have x cubed, 4th root of x cubed. Why? Because we will now have 5 4th root of x cubed over the 4th root of x to the 4th. And this is what makes it come out nice. So equals 5 4th root of x cubed all over x. Yeah, there we go. All right, number 32. The 7th root of m cubed. So we got to times by the 7th root of something. If we just did m cubed, when we times them, that would only get up to the 6th power. So we need 4. We have 3 of them. We need 7 to escape the world of 7th roots. We need a perfect 7th power. So we need to times it by something that will give us a perfect 7th power, and we already have 3 of them. So we get 9, 7th root of m to the 4th. That is irrational on the top, but on the bottom, we have m. No radical at all. Oh, that's nice. That's nice. All right, now number 33. 11 over the 5th root of 8. Now 8 is already 2 times 2 times 2. So this is really 11 over the 5th root of 2 cubed. So when we times it by something, we got to times it by the 5th root of 2. We need to make this up to a 5th power. It was nice up here because making this to a squared, we just times it by itself. But if we're trying to make this up to a 5th power, we don't want to do a 3. That would get us to 6. It's got to be 2 to the 2nd power because 2 plus 3 gives you 5. 2 squared. So we get 11 5th root of 2 squared is over the 5th root of 2 to the 5th. You see how we made this to be a perfect 5th so it could come out of there? This is now 11 5th root of 4 over 2. And there we have it.